Hi, my name is Rooji and I'm a student at Indian Institute of Science. Today I'm here to talk about the usage of replication coded storage to achieve low latency in distributed storage systems when the servers are memory constrained. This is a joint work with Ajay Badita, Pradeep Sarvepalli and Parimal Parag. Distributed storage systems has data stored across multiple servers in a distributed manner. One approach to minimize the file access delay in such systems is to introduce redundancy in data storage through coding and allowing this data to be accessed parallelly. And two most popular coding techniques are replication coding and maximum distance separable coding. We consider a setting where each server has a memory constraint and can store only a fraction of the file. Then we fragment the file into, say, V pieces, and then we replicate them at a rate R so that we have VR encoded fragments. Now, these encoded fragments will be placed over a system of B servers, each having the capacity to store alpha fraction of the file. So here we consider some examples where the file is divided into 2 and 4 fragments and they're replicated and stored over a system of 4 servers, each having the capacity to store half the fraction of the original file. So here we see that by introducing finer subfragmentation, we are allowing the 4 smaller subfragments to be served parallelly by the 4 servers, which is likely to cause a reduction in the download time of the file. And we shall refer to the placement of different fragments across these servers as the storage scheme. And we are interested in studying the storage schemes that will offer a good download time performance for the file. Next, we look at the file download. We consider a single request in the system and it will be forked into all B servers simultaneously and will start downloading the file fragments from these servers in succession. A request leaves the system only once it has gathered all the fragments which is necessary to decode the entire file. We introduce a parameter, the number of useful servers after else download, which is the number of servers which holds at least one fragment that is not yet downloaded. And now if the fragment download times are IID exponential with rate mu, then the joint rate at which the fragment will be downloaded will be NL times mu, as there are NL servers serving the request in parallel. And the question that we would like to address is to how to minimize the mean download time in such a system. And we see that the normalized mean download time is lower bounded by 1 divided by mu times the mean number of useful servers averaged over all fragments. So here we reformulate the problem and it is the following. So instead of minimizing the mean download time, we are interested in minimizing this lower bound, or in other words, we would like to find a storage scheme that maximizes the mean number of useful servers averaged over all fragments. And here is a summary of our work. We studied codes for distributed storage system with storage constraints and file subfragmentation for achieving low latency. And when download times are exponential, we reformulate the problem to maximize the mean number of useful servers, and we show that in this new setting, MPS codes are optimal. And when there are no memory constraints, even replication codes can achieve this optimal performance. Whereas when there is a memory constraint, we show that replication coding combined with probabilistic placement are optimal when the number of fragments are asymptotically large. So that's where I would like to conclude this talk. So if you are interested, please do check out our extended version of this video. Thank you so much for listening.